to the next handout, margin of error. Now, you hear about margin of error a lot when you're talking about political polling, like predicting who's going to win the race for governor or the race for president, or even, the school board or city council. You also hear margin of error when you're talking about medical studies. Exactly how accurate is our data? Well, mostly when you're talking about surveying people. Margin of error in a statistical study is used to describe a confidence interval that is likely to contain a true population parameter. Now, the actual technical definitions on how we get this margin of error is a little bit beyond the scope of what we're trying to figure out in this class. I just want to know, if I'm given a statistic and I'm told the margin of error, how can I interpret that? Okay. So if I'm told that City A conducted a survey of 100 people and determined that 40% are in favor of a new city park, and the margin of error is 5%, I am pretty sure that somewhere in between 35 and 45 people are in favor of the park. Okay. This is not guaranteeing me that 40% of the people are in favor of the park. My margin of error is 5%, so I could be off 5 either way. Does that make sense? So what does that mean when we are looking at studies here? So example 2. Company A makes cell phone batteries. And 3 years ago, a study was conducted, and it was determined that the average battery life was 40 hours. The margin of error was 3 hours. And after some modifications, a new study was conducted, and it was determined, there's supposed to be a D on the end of that, was determined that the battery life was 42 hours. Can the company claim that the improvements increase the battery life, and explain? Okay. Well, the old battery was tested at 40 hours. And my margin of error was 3 hours. So it really could be as low as 37. It could be as high as 43. The average battery life is probably within that range. Well, when we made the company made the improvements, the new battery had an average life of 42, which is about in there somewhere, right? So can I say that this new battery was better than this battery? No. This battery's life was somewhere in between 37 and 43. So I can't say that this was an improvement. So no. Can we say the improvements increase the battery life? No. And explain. 42 is within the confidence interval of the original study. Does everybody understand that? This margin of error is giving me a confidence interval, and it's saying the average life of the batteries was somewhere in between 37 and 43. So I can't say that 42 was an improvement. Okay, if I had 45, yeah, that would be an improvement because it'd be more than 43. But 42 is not. Okay, example 3. 2 weeks before the election, a poll was conducted to predict the winner of the race for mayor of Little Rock. The poll showed that 62% of the people would vote for Mr. Smith with a margin of error of 3%. However, only 55% voted for him. The polling company stated that the results were in line with their predictions. Do you agree? Well, they said 62% would vote for Mr. Smith. Margin of error of 3, so 3 less would be 59, 3 more would be 65. 55% actually voted for him, so 55 was over here. So was this 55 within the company's prediction? No. Okay. This is the prediction from the company. This was the actual percentage. So this actual percentage wasn't what the company predicted. So I could say no, 55% is outside of the confidence interval. Any questions with that? Okay, the next problem. In a CNN poll of 500 adults nationwide, 62% of those surveyed answered yes to the question, do you favor lowering the voting age to 17? The margin of error was 4.4 percentage points. Would you claim that the majority of Americans would support such a law? Americans would support such a law. So 62 was the percentage. The margin of error was plus or minus 4.4. So subtracting 4.4, get 57.6, adding 4.4, 66.4. So does the majority of Americans support a law? What does it mean by majority of Americans? It means more than 50%. Does more than 50% of people support lowering the voting age? And yes. And I could say the confidence interval is over 50%, which is a majority. Are there questions with that? Hey, Company A claims that 85% of their customers are happy with their products, a margin of error of 5%. And Company B claims that 89% of their customers are happy with their products with a margin of error of 5%. And can Company B claim that a greater percentage of their customers are happy with their products? And so we need to look at not just those specific percentages, but that confidence interval, that range that's going to encompass both ends of that confidence interval used that I find by using my margin of error. Okay, so Company A, let's see, they found that 85% of their customers are happy in a margin of error of 5%. So the actual number could be as low as 80. It could be as high as 90. Company B, they have 89% from their survey. Now I'm going to try to line this up. 89 is going to be just a little less to the left of 90 here. And there's a 5% error there. So this could be as low as 84, but it could be as high as 94. So what I want you to notice here is that there's an overlap right in there. The actual number of customers who are happy with company A probably lies in between 80 and 90. The actual number that are happy with company B lies in between 80 and 94. So what if the real number here was 90 and the real number here was 84? Then company A would actually have a better rating than company B. So just because we have the 80 and 85, 89 as our center points, doesn't mean that this company is definitely have a better happiness rating than this company. So can company B claim a greater percentage of their customers are happy with their products? The answer is no. Okay, the confidence intervals overlap. In order for this company to say that they are better than this company, this whole interval would have to be bigger than 90. Does that make sense? We're going to be talking about a confidence interval in the news. I got this news article from one of the news stations in Fayetteville, Arkansas, in the northern part of the state. And here's what part of their news article said. I know it's a little bit hard to read here. See if I can make this a little bit bigger. The poverty rate is about $25,000 for a family of 4. And there was a report that said that the percentage of Arkansas residents living in poverty rose from 16.3 to 16.8. And then it gave you a national average that said the national average rate of poverty fell. So there's not as many people living in poverty throughout the nation, but in Arkansas, our percentage rose. Okay. And they tell you down here, it says, however, the data collections are an inexact science leading to estimates based on what the census called a 90% confidence interval. With our book, we're using a 95% confidence interval. Okay, the estimates are based off samples which the Census Bureau acknowledges can lead to errors. And it says that sampling method does not fit all counties nationwide, but it does not know which ones. I think that's interesting. It doesn't know. It says that for Arkansas, the interval ranges from 16.3 to 17.3 from 2018, and from 15.9 to 16.7 for 2017. Those ranges that I was just talking about on my previous problem. So it says, taking the lowest poverty rate from 2018 and the highest from 2017, it's possible the state's poverty level actually fell. And I think that that's interesting for a couple of reasons. First of all, it's exactly like what we were just talking about with that example, that because the confidence intervals overlap, you don't know really whether one is better than the other one. And the second thing I find interesting about this is They are trying to explain to you about confidence intervals, which is exactly what we're doing in this class. I find it interesting that this news station is taking the time to try to explain to you how you should interpret the data and not make mistakes.
Now, like I said, I find it interesting that news station is trying to get you not to make mistakes with the data, but there are some times when news stations or newspapers or some type of news media intentionally gives you misleading data, and that's what we're going to talk about in the next lesson.